Hello, my name is Jenna Walker and I'm the project manager of Group 16 in LSU's Petroleum Engineering Fall 2016 Senior Design course. My fellow group mates include Alan Barahona, Ali Alchemies, and Amr Gandhi, and our senior design project is studying the effects of two-phase flow in a narrow annulus. Since last presenting, we have finished our literature review and picked out the most important things you will need to know to follow our project. To begin with, I'm going to tell you why we chose narrow annuli for our study and what we are going to define as a narrow annulus. We chose narrow annuli for our study because the oil and gas industry is doing a lot more underbalanced drilling nowadays, and it is a challenge to identify flow patterns and predict frictional pressure losses. And there aren't many studies out there on the effects of narrow annuli on drilling, and we want to enhance well control and improve safety. For our project, we are defining a narrow annulus as the ratio of dP over dH as less than or equal to 0.80.
Liquid holdup. Liquid hold is a very important factor in our senior project experiment. And for our completion of our experiment, we need to understand what liquid holdup cause and what is in importance for our senior project. Liquid holdup is when the gas is slipping by the liquids, emptying only a part of the liquids in a well and leaving a portion of the liquids in the wellbore. Why is liquid holdup an important parameter in our study? This is because it gives us the possibility to calculate and predict different parameters such as a mixture density and specific viscosity of liquid and gas. Also, the liquid holdup is really important to calculate hydrostatic head losses in many studies. It was argued that liquid holdup and pressure that can only be predicted by gas and liquid velocities. We will do our experiment to prove that we can predict them without measuring velocities. And
another important aspect of our topic is flow patterns. Flow patterns are generally the flow shapes that gas and liquid take, depending on the flow speed of both fluids. Fluid flow patterns are dictated by fluid properties and annulus geometry. In general, flow patterns can be divided to 5 main patterns. First one is bubble flow, where gas phase is dispersed into small bubbles in a continuous liquid phase. Second is dispersed bubble flow. It is the same as the bubble flow, but the bubble shape is more spherical in this one. Third is slug flow, where we have large gas bubbles moving upwards, followed by liquid slugs, which forms a continuous bridge at the outer boundary. Fourth is churn flow, and this looks like the slug flow, but it's more chaotic. The fifth is annular flow, where the gas is the continuous phase and liquid flows upward in wavy films around tubing and casing. There is also some small droplets in the gas column that goes upwards. These main shapes are what is accepted between the studies that we have looked at. Thank you.
The one of the important factor that plays an important role in our senior project is pressure drop. So what is pressure drop? Pressure drop is the difference in pressure between 2 points in a fluid carrying space. This parameter is dictated by friction losses that occur along a pipe. Why it is very important to study a pressure drop? Because we want to know the different flow regimes that exist in the annulus. So the different kinds of flow regimes are bubble flow, slug flow, churn flow, annular flow. So depending on the flow regime, we can correlate to the amount of pressure drop that can be created in the annulus, which is very important for us to know because it will affect the bottom hole pressure.